Hey, good morning everyone. My name is Yuri and this is the first live stream I'm gonna do in English. Всем привет, доброе утро. Скажите, все ли хорошо, и начнем. Yay. Is everything okay? The video, the sound? Yeah, so let's go. So today we're gonna decompile the animation that's been done for this website. Moray, I don't know how to pronounce that right, but I hope you can still read my English. So this is the animation. So you can move the mouse and you can see this nice effect, and you can also pay attention to the colors of those lines because they are different when they overlap with the text. So yeah, so that's what we're gonna do today. So let's get it started. As somebody who already seen my streams might remember the stream number 3 where we've done the particle cloud and the particle system with JavaScript, and this is gonna be a bit close. Sorry guys, it's gonna be in English this time. Yeah, and this effect is gonna be really close to the particle system, but it's gonna be with another take with the vectors and with a little bit more physics than the other time. So let's go ahead. I'm gonna set up the template. I'm gonna call it the name of the website, and let's get it started. Setting up the template. Installing all the dependencies. Yeah, and any feedback on my English is highly appreciated because I'm so shy about it. I'm not sure I can speak English actually. Is this the English language I'm speaking right now? It might be some Russian speaking language. Russian English, or Ukrainian English. Okay, so we need some time. Hello, brother Maxim. Brother from another mother. Yeah. So I just really like this effect, and actually this website, it just won the awards like 2 days ago, I think. It was in the awards, or maybe 3 days ago. Oh my god, where's the awards? I guess it was among the winners. Yeah, so it was 3 days ago. It won the awards, and I'm coming to this website every day and checking out the new animations, and I just really like this new take on the particle systems. And yeah, let's make it. Oh, come on. Install it finally. Well, anyhow, we can start coding. We don't need to wait for all dependencies. So let's do it. Yeah, thank you guys for all the support. Yeah, so let's get it started. So what I would need here is a dot class for each of those dots, and the class that will control all those dots. So I'm gonna start with the class that will control all those dots. It's gonna be just the generic one which creates the canvas and creates the request animation frame, and let's make it happen. It's gonna be class. I'm gonna call it cloud on the constructor. It's gonna create the canvas. It will also have this update part, which gonna make window. So I'm just creating a structure right now. Frame, and I'm gonna run this exec class, but I will need to bind the object here. Yeah, and let's create just the time 0, and I will just update the time on this update function. And what I'm gonna do in the end of the construction, I'm gonna just run this update thing. So it's gonna, all it's gonna do is just console log this time variable. So I'm gonna get the growing number on the console. Hopefully, yeah. So did the install finished? Yeah. So I can run the template. It's just a gulp with a webpack. Yeah, I don't need to put the brackets there. So it runs okay, and it should output what? What? Oh, I need to initiate the class. Still not run automatically for me. And yeah, I'm getting this growing number, which is just growing each frame, each 1/16 of the second by 1. Yeah. I'm sorry guys, I don't know how to turn on the Russian subtitles. But the stream number 3 is mostly about the same technique, so you can just watch that one and maybe you can catch everything I'm gonna do here. It's gonna be just almost the same, but a little bit different, So I created this whole structure. I also would need to create some particles. Create particles here, and I'm gonna put this method, create particles. But to create some particles, I would need actually a particle class, yeah? So I would start with import thin, because I'm not sure it's actually a dot. It's not a dot, it's a line, and it's if you zoom into this one, it's like a small, just really small line. Yeah. Датчет переводить просто создаю пока класс базовый. Yeah. So I'm gonna create particles, and I'm gonna add a new variable, which is number of particles. Let it be 100 for now. And then I'm gonna create this loop for that number, and I need to do something here, right? And I also would need to create a canvas, I think. Yeah, I put this comment here. I actually have this snippet I created specifically to create this canvas faster. So I'm gonna just create the canvas element, get the context, get the width and height of the window, and then set canvas to be the whole window. I also put this here, and then I'm gonna just add this canvas to the document element. I'm gonna remove all this stuff that's here, and what we should see right now is just hopefully no errors in the console. It's just a canvas, but I just need to be sure it's already there. It needs to be there, but it's not there somehow. Why it's not there? Document body append child, this canvas, it should be appended. Maybe I'm getting some error here. Oh, I just didn't finish writing the line. Import thing from, this is a mistake thing, and I'm gonna create just an empty JavaScript file for this thing. Yeah, so it should be fine right now. Still some errors. Let's check it out. Please create particles. Create particles. What the mistake is there? Number of particles is 100. Number of particles, create particles. So what's wrong here? Where did you go the wrong way? Please create particles. Unexpected total. Oh, it's the wrong symbol. Actually, my screen is so dirty I couldn't see that it's the wrong wrong chart over there. Yes, now we get some other mistakes, which is canvas is not defined. I should put this over here also. Yeah, now it's okay. Now this time is not growing. I should remove this console log already. Yeah, now I should get finally the canvas inside of my page. Yeah, so if you see this kind of context menu, it means that it's actually a canvas all over the place. I can just check it out. Yeah, this is the canvas with the height and the width of the window. Nice. So the next thing I'm gonna do, I'm gonna create the class for my particles. Let's assume our particles is just some kind of circles right now. So I'm gonna do this export default class, export default, because I'm gonna be exporting it into the other file, to the app.js. Yeah, I'm gonna call it a thin, some kind of thin. It's gonna have a constructor, and in constructor, I guess I would set the context, because I would need to draw this thing into the canvas, and I would also need to set the x and y, the coordinates. I would also need the class which is gonna draw something, and like this. And I would also need the method. That's not a class, the method. The method is gonna It's gonna update things. So in the constructor, I'm gonna just set like this context is actually this context, which I'm getting here from some upper class. And the next thing is gonna be, I'm gonna set the X. But let's stop over here for a second, because initially when I did some particle systems, I used this kind of thing. I used like pos X, and then I set the X. And then I used like this pos y, and then I set y. But then it's actually a vector, it's actually two-dimensional vector, and all the things I'm gonna do with this two variables is actually adding or multiplying by some vectors. So it's easier to use vectors. And what's interesting, while I decompiled this effect for the website, I found out that the guys actually using this library, which is called GL Matrix. It has nothing to do with actual GL. It might be useful for GL application, but it has no WebGL inside of it. It's just a mathematical thing, you know. It's just, if you use the documentation. Oh, thank you guys. If you use documentation, it actually has some helper classes for multiplying matrices, for multiplying vectors, and all the other stuff. So it's just helpful to not write your own classes for multiplying two-dimensional vectors, because I can go here and it has all the methods already, like the add-in vectors. It has the method to clone the vector, obviously, to copy, to create an empty vector, to make a cross product of the vectors also, and to get the length of the vector also, yeah, which is gonna be the most useful part for us right now. So gonna be just adding vectors and then measuring the length. Yeah. So let's assume the coordinates of each dot is actually a two-dimensional vector. So to initiate the coordinates of this thing, I'm gonna do just this. So this position equals back2, but first I would need to import the GL matrix. Imports goes like this. So I'm only getting the two-dimensional vector part from this GL matrix, and the whole library is actually not that big. It's just a couple of kilobytes. It's not big, so it's really just the helpers. Yeah. So I'm gonna do the vector2 and create from values. So this is just the method to create the vector from existing values. From values xy. Yeah, that's it. I will also need the original position of the dot. I'm gonna do it the same, because there's gonna be the one position from the dot I'm gonna be changing all the time, like this one. But I would need to save the original also. What else? Each dot gonna have its velocity. So let's assume the velocity is also a two-dimensional vector, because the dot can move in any direction in a two-dimensional space, so it's actually a two-dimensional vector. And let's assume it's just 0 by default. Yeah, and the next thing, we also have the acceleration. It's going to be also 0 by default. Yeah, I think that's it for now. So I would also need the method to draw this particle. I would just get default thing canvas arc. Yeah, so I'm gonna just draw a circle. I'm just copy pasting developer, Stack Overflow driven development. Yeah, so I already have the context. It's just this context, and I can draw the circle, but I would need to change the coordinates, because first two numbers is actually the coordinates of the circle, and those gonna be just this pos 1. Actually, this two-dimensional vector, it's just an array of 2 values. Yeah, so you can just get like this and 1. And that's it, I think. Yeah, so we can draw now something. So finally, by this point, I hope we can see something. I would also need to create an array of my dots, just particles array. And then I'm gonna create particles. What I'm gonna do there, I'm gonna just these particles, push something new there, and the thing is gonna be new there. It's gonna be this thing, and I'm gonna need to, just so we not mess with the context, I'll create self, which is equal to this. It's gonna be self context, which is already set over here, and it's gonna be the x and y coordinates. And for now, I can just put a random number like this, random multiplied by widths, by this widths, by self widths. Yeah, and the same one for the y coordinates, but multiplied by height. So yeah, so I'm creating the particles. Right now I do have particles, but I'm not doing anything in update method. So what I'm gonna do here is just to draw them. So I'm gonna do these particles for each. Well, hopefully it's not that too much for you, because we can't see anything for now, but well, it's coming guys, in a second. Yeah, and what I'm gonna do here is just p draw. That's it. So I'm gonna just draw the particles in a loop, in this request animation loop. I would also need to install the GL matrix thing, yeah, because I'm getting this error here. Yarnet GL matrix. Somehow I need to restart the webpack each time I'm installing new dependency. I don't know why. It's caching the existing dependencies, I guess. So yeah, it's restarted, and hopefully we would see a lot of circles, but no, thing is not defined. It's from the capital T. Failed to execute arc on a, why did it fail? This context. 5 arguments required, but I just deleted the radius argument from this canvas arc. So let it be, the radius is gonna be just 10 pixels. Because it needs 5 arguments and I provided just 4. So yeah, so now we have something to see at least. So just random circles all the way through the canvas, but we already have the class. It's a separate thing. We can put some physics, some animations over there into the class, and we can control this class from the main application JavaScript. So mostly I think that's it for this app.js. All the other stuff would go into the thin.js. I just hope it's clear for now. Yes, guys, I do pronounce height with a hate. I don't know, I just, as a Russian native, I just get used to reading it just how it reads in Russian. I'm gonna try to fix it. Height. Yeah, sure, you can use it, but you will need to transpile this class, because it's not supported in all the browsers right now. Because I'm using Webpack here with a Babel enabled, and the Babel is transpiling this class notation into the usual JavaScript, which could be understood by any which could be understood by any browser actually, but you can't use it as is just in JavaScript without transpiling for now. Yeah, I can try to speak Russian, but I'm like doing this the whole life, so I'm pretty sure I can speak Russian actually. Yeah, but you guys can actually ask me something in Russian, it's no problem at all. So yeah, let's move on. So we have this thing, let's just have this time here in update, and I'm gonna add the update method just so we can see something moving right now. Self time, self, just to avoid all the context clashes. So I'm gonna update particles first and then draw them. And what I'm gonna do here, I'm gonna just change these positions. They're all gonna be like this: original 0 plus mass sign multiplied by 20, for example. Let's just do this. Yeah, it's gonna be the only thing that I updated. I'm gonna change the position, the first argument of the position, and I'm gonna see something. I hope so. But we are not seeing anything. Why? I guess, oh yeah. So now you can see this weird animation. And you know what? That's because I forgot to clear the canvas. So on each frame I would need to clear the canvas first and then draw something. So I would need to this context, clear rect, and gonna be this width, this height, this height. Yeah, so now get this crazy shaking animation. We can just slow it down, but you know, just the sign, it's just so we can see something. Yeah, so we can actually move those particles. It doesn't look any close to this, right? Yeah, but we are getting there in a second. For now we just need to figure out the physics and all the stuff. Yeah, so the next thing I'm gonna do, actually need those particles to react to my mouse, because on this website they actually reacting to my mouse movement. So I would need to bind some mouse events also. So I'm gonna do this bind mouse. And what I'm gonna do in this method, and just gonna bind, ouch, bind mouse. I'm gonna just put this canvas add event listener mouse move function, and then I'm gonna just console log the event. I think I can just remember that it's called like this. So I'm gonna get the coordinates of my mouse over the canvas right now. Well, the guy's asking what's my take on the block schemes, but I'm just not programming that much to use them, you know. Maybe that's why I'm just a light kind of a programmer. I'm just doing the chaotic stuff, and then I'm trying to figure out in the end how to reformat it so it could be understood by someone in this world. Does it depend on the power of the computer or fixed value? What exactly? How many times per second the update works? No, it works 16 times per second, and this is like inside the browser, because this is how the request animation frame actually works, and this is why its function was created, just so we can have 60 frames per second in the browser. So it tries to run each one 60th of a second, but if you have a lot of computations over here, it might go a little bit longer, and that's where you see the FPS down. Yeah, so we have an update, we have a draw. So we finally would need to use the vectors and the math and the physics, I think. Yeah, reacting to the mouse. I would need to check in the console whether I get in this. Yeah, so I'm actually getting this. It's 0, 0 on the left corner, and it's the maximum width and height on the bottom right corner. So I'm actually getting them, and I'm gonna just set this I stumbled on this mistake so many times, and I'm trying to create always a self variable. So I'm gonna just set the mouse position. Mouse X gonna be E client X, and the mouse Y gonna be client Y. And I'm gonna just initiate those variables, so they're gonna be just at 0. Mouse X gonna be 0, mouse Y gonna be 0 also. Yeah, so now I'm having a mouse, so now I need particles to react somehow to my mouse. Yeah. How to do that? I think I would wrap those methods. So I would need to use the velocity and the acceleration right now. So instead of just blindly updating the position with math sign, I think I would need to calculate the position from the velocity and from the acceleration. And to do this kind of thing, I would actually need to use the vector2 method, and it's going to be like this. Vector2, I'm going to add this position. This is the variable that's going to be added to the result of the adding, and I'm going to add this position, this velocity. So I'm just on each frame, I'm going to add my current velocity to my current position, and it's gonna be going into this position variable. Actually, if you check the documentation, yeah, so that method, it actually has the out vector, which is going to be the result of adding those two vectors. But in my situation, I just need to update this position, so it's kind of double this position. So I'm going to add velocity to my current position, which is just moving the particle according to its velocity. Then I'm going to add this velocity to this current acceleration. It's going to be this velocity, this acceleration. For now, all those are just 0. They are not changing in any way. And on each frame, I would also need to make acceleration 0, because I would set on each frame new acceleration to the particle, because I would calculate the acceleration judging from the position of the mouse. So what I'm going to do, I'm going to just scale. It's just a multiplying, another way of multiplying the two-dimensional vector. So I'm going to multiply this acceleration by 0. So I'm going to set the acceleration by 0, because I'm going to be setting this acceleration in the other part of my script. So the first thing I would like to do, I would like my particles to run away from my mouse. So I already set the update thing. I can actually right now, I can just put the random velocity over here, and we can just see something, because it should be updating right now. So I'm just math random multiplied by, I don't know, 2. So the velocity is quite small, but still. And I can even, I can subtract the 1. So it means that the number I'm getting here is from -1 to 1. So it might be negative also. Yeah, and let's see how is it working right now. It's not working right now because back is not defined. I forgot to put 2 here. Yeah, so now we have this random brown movement. So I don't know. So each particle has random velocity in each direction, and the velocity is actually a two-dimensional vector also, which is kind of obvious right now because it's pointing in some direction. And what I'm having here, they are just running away, and yeah, so they're not getting back. So the next thing I'm going to try to do, I'm going to make this velocity dependent from the mouse position. So I'm going to be back with zeros. And you can actually have a lot of fun with those, because this particle approach, it could be transmitted to the 3D, to the two-dimensional things. You can just draw some images instead of the particles. You can do whatever you like. And actually it might be fun just for a second to remove the clear react thing, and we would see this kind of thing. You might have seen it in some animations, because we're not deleting the old drawn particles, so it's just going all the way. But the FPS is actually, well, it's actually okay. I thought it's gonna be a lot less than that, but it works pretty nice actually. It might be even more beautiful if we make the radius something like 2. Yeah, so this is the contemporary art right now. I can just make a screenshot, print it, and sell it for 1,002 maybe. But it's beautiful. Okay, so I have these particles and I would need them to react to the mouse movement. How to do that? I would need to create some kind of structure for my physics. I actually borrow that kind of structure from the guys from this website, because I'm always trying to learn something new from the guys. That's why I'm trying to replicate exactly the same thing they did in their animation. So I'm gonna change. Yeah, actually I think that's it with the application.js. I can even close it right now. For now, yeah, I would need some method which is called physics. And in physics, I would actually calculate runaway movement, and then you can see that after the particles are running away, they're getting back. So I have two forces. One is running away, and another one is calc going home. I would also add the methods apply force, which is gonna just apply force. And by applying force, I mean that I'm just gonna set this acceleration. I'm gonna just add to the current acceleration this force. The force is actually the force and acceleration is actually the same thing, because if as you might remember in physics, the force is actually an acceleration multiplied by mass. But we don't have any math, so the force is actually acceleration. Yes, I'm gonna just add this acceleration and force. That's it. Quite easy. So I would need to, and this force is gonna be a two-dimensional vector also, right? So I would need to calculate those two forces here and then apply them. So I'm gonna this apply force, runaway force. I would also apply going home force. Let it be like this. Going home force. And what else? I would need to calculate them actually. For now, I'm just gonna set them. Runaway force. It's gonna be vec2 from values 0, 0. And the going home force, the same one. So I can just maybe put some, let's just check it still works. And what I also would need, I would need to get the mouse position over here, and I would need to run this physics. Yes, sorry guys, it's English content. Hopefully you can get a grip of what I'm talking about right now, because it's not only English, it's also a bit complicated as an idea also, not just as something you would need to translate and it's easy. No, it's an idea which is a bit, you need to think about it to get it. Yeah, so I'm just thinking about the structure right now. So I have this physics method, I have this apply force method which is used inside this physics method, and we also need two methods to calculate those forces actually. I would just call them runaway, and I'll call the other one going home. So for runaway movement, which I'm gonna start with, I would need actually the coordinates, the coordinates of the mouse, because I just need them to calculate where the particle gonna run away. Yep. What else? What else? And let it return this exactly vector, runaway force. Just gonna return this runaway thing, always 0, and I'm gonna do it like this. So let it run away. So instead of just setting the vector, I'm just running the function run away, which is returning a vector right now. And hopefully it still works, but I would need the xy also, and I would need those xy in my physics. So I would need to run this physics before my update and draw. So before those things, physics is gonna just calculate the acceleration, the velocity, and the update gonna set the new position and the new velocity, and the draw gonna be just drawing all the stuff that's calculated already. So I'm gonna have this mouse x and self mouse y. Yeah, I do have it right now. Self mouse x, self mouse y. It's a bit long shot right now because we're not seeing anything, but we're trying to do the physics part. But just 1 second, we're gonna see something. So it's calculating runaway force. Yeah, well, at least it should still show me the particles. Yeah, it does show me the particles. I'm gonna set the velocity to 0 again, so they're not moving. I'm gonna bring back the clear X thing, so they're not drawing again. And I'm gonna, in this runaway thing, I'm gonna just calculate the acceleration as always in one direction. So yeah, you can see they are just falling as if the gravity is working right now. So it's actually working right now, and I can just set the acceleration a little bit lower, and I think this is going to be the maximum value that I'm going to be using in my library, so the particles would not go too fast. I'm going to just create it. Naming methods with verbs, but like going home, yeah, I think the calculate forces is quite okay. Let it be the calculate forces, and let's use it. Yeah, I think that's better. And in the application, just instead of physics, I'm gonna just calculate the forces. Okay, it's just 2 times, it's in my JavaScript, so it's not hard to change it for now. Yeah, so the runaway thing is working, but I would need to calculate right now, like, how should it run away. So I'm gonna start with calculating the distance between the mouse position and the position of the current dot, and the distance is gonna be just, it'll be the empty vector for now. The empty vector, which is gonna just create the empty vector, which is gonna serve the resulting thing for the calculating distance. And then I'm gonna just do vec2 subtract. So I'm subtracting one vector from another into this dist thing, and it's gonna go into this let mouse equals to vec2 create from values. I'm gonna just create a 2-dimensional vector from the mouse position, which is just xy. So here I'm gonna subtract the mouse position from the current position of the dot of the thing. So yes, I'm getting this right now. Now I would also, you can see that I'm not engaging all the particles at the same time, so it has some radius of my force, right? So to get this radius, I would actually need to get this like vec2 length of the dist, which is just the length of the vector which is pointing in direction, which is just exactly the distance between 2 points, between the mouse and this position. So the dist vector is actually the vector of the distance, and the length of this vector is actually the distance. Yeah. And if it's less than 100, so it's going to be the radius of my power, of my force, it's going to be just 100 pixels. I'm going to just log like force should work right now. I'm gonna just check if it's working at all. Maybe I get some errors. M is not defined. Yeah, because it's mouse. Yeah. Force should work, yeah. So it's because I have a lot of particles right now and the radius is 100 pixels, the forces should be working almost all the time because I'm overlapping with any particles too often. Yeah, sorry guys. Hopefully you can understand this in Russian. You can just, вы можете посмотреть просто стрим номер 3. Там было похоже рассказано. Я, наверное, могу иногда говорить что-то по-русски, какая разница. Yeah. So we're almost there. I will just try this method. So if the distance is less than that, I would need to calculate the actual acceleration, the force, the fleeing force, the runaway force for this particle. So the first thing I'm gonna do, I'm gonna add the helpers functions, 2 helper functions, which I created already for me. Somehow they're absent in the GL matrix thing, but I'm gonna explain what they're doing right now. So the first function is actually setting the magnitude of the vector. It's not normalizing vector and then multiplying it by some number. So t and e is actually the coordinates of the vector and the n is a multiplier. Yeah. So the t is a resulting vector, the e is the vector I'm multiplying, and the n is actually the multiplier. And also the function which is limiting, which is serving kind of maximum. So I'm gonna restrict my maximum force and restrict my maximum speed with this function. I just, as you can see, they are obfuscated. The variables are named pretty ugly. I just got them from the obfuscated code from this website. So this is kind of the way I'm decompiling the websites. So if you just look in the website, you can just see those 2 helper functions because the guys could not replicate these same functions with GL matrix, and I guess they just created their own just to make those calculations. So the first thing I'm gonna do, I'm gonna multiply my distance vector with the maximum speed. Yeah. And I will also need the maximum speed. Let it be just 5 pixels per second is pretty fast actually. I would also need this max speed thing. It's gonna be 5. Is it gonna be 5? I just know the 5 is the right number, okay? In real life, you would need to test 4, 5, 6, 7, 10, 8, and depending on the behavior you like, you can change that. Yeah, so the next thing, I'm just losing the context here. Yeah, so I need to calculate something here, calculate something dependent on the mouse. As I already said, the first thing I'm going to set the magnitude of the vector. So I'm going to update the dist with this max speed. So I'm setting the vector right now, the distance vector, which is pointing in some direction to the maximum speed, which is 5. So it doesn't matter the distance that was actually before. The length of the vector right now gonna be just 5. Okay, it's just kind of dividing the distance, so we would not have the speed like 100. We need to divide it. We need to normalize it to the maximum speed. Yeah, and the next thing I'm gonna do, I'm gonna revert this this vector. Well, maybe not for now. So I'm gonna just create this let run away force, which is gonna be just an empty vector. What's the difference between speed and velocity actually? I'm not sure there is one. Speed and velocity. I'm mostly using velocities from physics, I think, and the speed is from something, the common life thing. Yep. So we're gonna be calculating this runaway force, and to calculate the actual acceleration, because the force is actually an acceleration, and to calculate this acceleration, I would need to subtract this calculated speed, but subtract. I would need to calculate to subtract the result. I'm gonna write into this runaway force, and I'm gonna the dist, which is the maximum speed, minus current velocity, which is just this velocity. And this is going to be the actual acceleration I would need to set on each particles. Let's just also limit this one. So it's going to be limit runaway force with this max force. So this is just limiting the maximum number. And let's see, and I would need to also to return this one, to return the runaway force, because this function needs to return the force. But by default, it's gonna be returning this one. So I would need to change it right now. So it's just a 0. And let's see, does it? Yeah, it does work. Now it works in the opposite way. I need it to work because it's actually attracting all the particles. But this is the simplest kind of physics we can get here. So not to attract particles, but to make them flee, I would need to multiply the dist. I would need to set dist to vector 2 scales, which is all just the multiplying dist, right to dist minus 1. And now let's see what we have. Yeah. And now you can see that I'm just make them run away from my mouse. And I can just stop them and play with them. So it does work actually. And they have the maximum speed. They're not running away very fast. Even if I'm trying to push them as fast as I can, they're not running fast. So they're kind of elastic. It's nice ones. I can make them a little bit bigger, so it's easier to see. Yeah. So like this. So now they're fleeing from my mouse. So the part for the runaway is actually done. It's not that obvious to understand it because all that we did, we were calculating some vectors, but hopefully you can understand, because like in this part we're just calculating the distance between the mouse and the particle, and if the distance is less than 100, then something. If it's not, it's just the acceleration going to be 0. The force is not working on the particle if the distance is more than 100. So if the distance is less than 100, we then normalize the distance vector to the maximum speed, and then we subtract the current velocity from this maximum speed, then normalize it, and we're getting the actual acceleration we would need to add to the particles. And then we just limit it so it's not growing all the time, because if I'm not limiting it, I can make them even faster. I guess the maximum speed is limiting it here, but if I'm removing this magnitude, you see what's happening. The speed is growing very, very fast. That's why I need those two limiting things. Yeah. So now we have it. Now we need to calculate another force, which is going home force. This going home force, and for this force I would only need to calculate this whole going home force. I would only need the original position of the particle and the current position from the particle. So I don't need the mouse position to calculate this force. So this is going to be going home force. Let's calculate the distance, which is going to be again two-dimensional vector. So the thing I wanted to learn, and maybe I wanted to somebody to understand also from these particle systems, is the way that guys been using the vectors to calculate all this stuff. It's a little bit more understandable than not using vectors actually, because in one of my first streams I used to calculate just the coordinates, and it's not so clear what's actually happening, not so clear the physics behind all this stuff. And now in this way of doing the particle system is actually pretty clear, the physical part, because you have the forces, you have the acceleration, you have the velocity, and the update thing is actually the classical physics updating of the particle. So it's pretty clear for me right now what's happening there. So let's calculate another distance. We need to calculate the distance of the particle from its original position. So it's going to be another vector to helper method, subtract to get the distance. I'm going to write it to distance vector, and I'm going to just subtract original from this pos. That's it. And I'm going to calculate also the length of this vector. Length is going to be just vector length dist. So this length variable is actually the distance between the current and the fleeing position of the particle, right? And what I'm gonna do also here, I'm gonna return the 0 vector by default. So it's working right now. So going home is actually going home force. And it's wrong naming. So now I'm going to calculate the distance between its fleeing position of the particle and the original position from the particle. And depending on this distance, I would need to calculate the acceleration. So the further the particle goes from its original position, the more acceleration should be to bring it back. The more force would be to bring it back to its original position. Yeah. So let's by default. Yeah, no, not like this. So if length is less than 100, I'm gonna do the calculation of the speed. It's speed coefficient. I think it's like this. So it's gonna be this max speed multiplied by length divided by 100. So what we are doing right here, so depending on the distance of the particle, so if the distance from the original position is 100 or then the speed gonna be the maximum speed, because this one gonna be just equal to 1. So the max speed gonna be just the maximum speed. The speed coefficient gonna be just the maximum speed. And by default, I would set this speed coefficient to something even bigger than that, to 8. So if the particle goes further away than 100 pixels, the speed coefficient is going to be really, really big. So it's going to bring back the particle really fast. Yeah. I would also need... Why I need this... speed coefficient to calculate the actual force, right? And the force is so I'm gonna just set magnitude of this dist vector. Actually, this dist thing serves us two purposes. The first one is that we're getting the length of the vector, we're getting the distance, and the second one we actually having the direction, the vector that the particle should go back to its original position. Да, то есть, короче, это... Кстати, подожди, печатка. Этот вектор, он нам служит двум целям. Первое, мы считаем расстояние, на которое частичка улетела от своей родной позиции, а второе это направление, то есть вектор это же направление. And I'm gonna switch back to English again. Yeah. So we're gonna use this speed coefficient to multiply the distance vector to set the magnitude of distance vector, because this speed coefficient is actually the power of the force that's bringing back the particle. Yeah. So I'm gonna just set this dist, and the speed coefficient. So I'm just setting the vector of the distance to the speed coefficient value. So the speed, this is actually the speed that's bringing particle back. Now we only have to calculate the force right now. Back to create. And then I would need this force to be the subtraction just the same way as here. I'm gonna just subtract it, but not runaway force, but the usual force. And I'm gonna also limit it the same way there, and I'm gonna return it. Return the force. Yeah. So now we have all the calculations that needed to calculate this, to get this force actually. So we are calculating this force depending on the distance of the particle from its original position. The speed would be different. So if the distance from the particle from original position is like just 5 pixels, so the speed is gonna be just really slow, because it's gonna be 5 divided by 100 and then multiplied by the maximum speed. So it's gonna be just 1/20th of the maximum speed. So it's gonna be really slow. So they're gonna be fast on the end, but really slow when they're coming back. And let's see what we have here. Some error, speed coefficient is not defined. Yeah, I think I would need to make it like this. Runaway force is not defined. What do you mean? Oh, I think I copy pasted the runaway force. Yeah, I need just the usual force. Yeah, now it's okay. So now you see we have this physics part doing its job right now. So when I'm moving my mouse, the particle runs away, but when I'm putting my mouse away, the particle goes back. So yeah, that's it. Now let's create the final effect. We actually have everything we need right now to create this effect. It's just one small step left. First of all, let's do the black background thing. I'm gonna just do the body, background black. Everything looks nicer on black. The next thing I'm gonna do, this context, I'm gonna create the stroke style in my application. This CDX stroke style, which is equal to RGBA. It'll be white with a little bit of transparency. Yeah. So now I'm seeing those circles, they're a little bit transparent, but it's still not the thing I want, right? The next thing I would like to do, I would actually like to draw not circles, but lines. Where do I have it? In my draw method. I would just make it like this, close path. And instead of an arc drawing method, I'm gonna use this. I'm gonna just move context to this original position, not original, but to this current position, and then I'm gonna create this line too to this original 0, this original 1. Yeah, that should do the trick. So I'm actually just drawing the lines right now. Oh, I'm not gonna draw the arc anymore. So now you can see almost the same effect, but it's still not there. So a couple of small things left. First of all, they have it in a disk, right? So let's generate all those particles we're generating to the disk. To do this, it's not that hard actually. I would need to calculate the positions. It's not gonna be just random. It's gonna be, let it be XX and YY. And I'm gonna pre-calculate those XX and YY. So to calculate a random dot inside a circle, I would need the radius. The radius, let it be just 100. I would also need angle, which is gonna equal to 2 multiplied by math p multiplied by math random. So just a random angle. And then I'm gonna just calculate the xx. So it's gonna be 200. This is gonna be the center of the circle. We already did this kind of thing in some other streams. And gonna be radius multiplied by mass sine of an angle. And it's gonna be the same for the yy part, but it's gonna be cosinus. Yeah, so it's now on a circle, but it's not inside circle. So the only thing left, I actually need to multiply this also by math random. So the radius is going to be random also. So now we have circle, but it's not enough particles. I think the guy's using like 2000 particles at least in their website. Now it looks almost as we want it to look, but you can see that in the end of the animation I can't see anything because the particles are not actually moving. To fix this, I would just add another position which is a bit shifted to the particle. So I have the original, I have the position, and I want to have this shifted position, which is going to be a vector from values, which is going to be x plus math random multiplied by 2, and the same for the y coordinates. And instead of drawing from the original to position, because in the certain state the position is actually the same as original, I would draw to this shifted, which is just random 2 pixels shifted from the original position. So I would draw this line to shift it, not to original but to shift it. And let's see what we have here. So yeah, now we have it even in static. We do see the particles, but as you can see, the random is not that random right now because we have more particles inside the circle than the outside. But anyway, it's working right now. But let's put the circle in the center of the screen. And how to do that? I should just add the half of the height and the half of the width instead of those. So it's going to be this width divided by 2 and this height divided by 2. So now the circle is going to be in the center. Yeah, we do have it. I can make the radius a little bit more than that. Yeah. Now it's interesting that we can actually fix this, make the distribution of the points more uniform, because right now we have less particles on the end of the disks and more particles inside the disk. So what's left is actually, let's make it a uniform distribution, and the easiest thing to make it a uniform distribution is actually to use a square root here. So instead of so I'm gonna do right this. So I'm gonna make a power of 2 for the radius, and then I'm gonna multiply it by math random, and then I'm gonna take a square root from this, and this will make the distribution of the points inside the disk uniform. I don't know what's the point of the XX and YY, just so it's not clashing with all the XYs in a different locations. Actually, there is no point to do this. I can just make it an X and Y. You're right. I just sometimes like to name it more safe, like XX. I don't have any XX. it's not yet working the way I expected, because I'm still multiplying it by the math random, and I would only need to multiply it by the radius right now. Yeah, so now you have it, the uniform distribution. Now you can see where I was heading, right? Because it looks more beautiful than it was before. Now it's almost the same that we have in this. You can even miss it. The only part which is left is the coloring, and it's actually so simple. Let's just put the white text over our canvas right now. So I'm gonna have this text. I'm gonna make it absolute left. I'm just putting it into center. -50, -50. Yeah, I'm just gonna add this text. Hello guys. Yeah, it didn't fit. Let it be just hello, okay? It's not yet working the way it's expected, and you can also see that the mouse movement is missed when the mouse is over the text. To fix this, I would just need to add the pointer when it's none. This is actually exactly the application of this CSS property. So now it's gonna work even when I'm over the text. And now only one CSS line left to implement the final effect, and I'm gonna just copy paste it directly from this website. So I'm going to this H1, and this is this line, you see, which does the rest of the magic. It's just the mix blend mode. So I'm gonna add this mix blend mode exclusion, and yeah, we have it. This is the final effect, and this is actually 99% the same as they have it on their website, and we still have those 60 FPS, and it's working pretty nice. That's it. You know, it's so beautiful, it's so addictive. You can just hover them over and over again. I can make particles, not the number of particles, even more than that. I think the computer should be okay. You can make it 8,000. Yeah, now it's just magic, but the FPS is down, you see. But yeah, still it's magic. Maybe less than that, maybe 4,000 is okay. Yeah, it's just 60 FPS all the time, and it looks beautiful. That's it. Oh, that was the first stream in English. It's a bit hard to speak English for such a long time because I'm not having any practice right now, but hopefully you like the effect, and it's so simple. It's almost the same idea as I had in the stream number 3. I can just remind you what it's been about. That's stream number 3. It looks different, but the idea behind is the same, exactly the same. This was the effect I did in the stream number 3, and you can just rewatch it, and it's almost the same idea in Russian, but without the vectors. I'm just calculating all the positions from the coordinates exactly. But it's magic for me that this and this is actually the same thing. This is 90% of the code is actually the same for implementing this and this. And this is magic, yeah, right? So hopefully you understand all the vectors part, because the most complicated part of all this stuff is actually using a vector. But it's once you understand what's actually two-dimensional vector, it's even easier than that. So you can just use the vectors all around, and it's starting to be simpler than that for you, because less code, less computations, it's more obvious, more closer to the physics, closer to the actual physics. Yeah. Я надеюсь, пацаны, вам понравилось, и мой английский был не такой ужасный. Хотя, конечно, шутить получается меньше на английском. Да, потому что держать в голове и английский, и еще этот сложный эффект, который ты пытаешься сделать, это тяжеловато. Но я ради этого все это и делаю. Ну круто же, круто же. Это же классная штука. Так просто и так круто. Yeah, thank you, Pavlo, and thank you for appreciating my English. I know it's not perfect. I know I'm using this hate thing instead of hide, but I'm gonna fix it. I'm gonna fix it. So thank you guys. If you have any questions, if you have any propositions, what effects you would like me to decompile, I'm trying to decompile new stuff all the time. As you can see on my desktop, I have like 5 or 6 maybe websites which I'm decompiling at the same time in a different stage. Some of them are almost decompiled already, some animations, some are not. I also wanted to use this animation, but I'm still in progress of decompiling it. It's also a cool one. I'm just gonna show a preview. Yeah, this one. Nice. Yeah, but it uses a lot of math also, so it's a bit complicated to get into this one. But it's looking beautiful and so addictive also. I can watch all the day to this one. So I'm gonna stay in chat for a couple of minutes more, and if you have something to say, I'm gonna be grateful for you. And it was nice to see everybody. Thank you for watching my streams. If you want, you can even support me with some money. It's not a big money. You can find a link down the YouTube video, and it's not obligatory at all. I have some money, obviously. I have some money. Спасибо, ребята, за поддержку всем, особенно с английским языком, потому что это тяжело и все такое. Спасибо, Аня. I love you, Аня. Yeah, I think using the idea is a good idea actually, but I'm used to this simple Sublime text editor, and I just like the coloring, I just like all the stuff. Sometimes I'm trying to use the Visual Studio Code, but I'm not yet a switcher to the Visual Studio Code. Yay! So guys, have a nice day, have a nice week, have a nice year, be happy and do all the new animations, and I hope I can inspire you for a little more. Bye.